right, sir.
So, as we were saying, I said, what is enterprise and machine learning? When you look at this architecture that is right in front of you and I, you can see this very structured architecture. So this is what enterprise and machine learning looks like. It looks like. You can see by your left-hand side here, you can see your models, you can see the data and the code, and you can see the processes that goes in from data injection to validation. You can see data being validated, raw data being fed in, the processing going on. I know you know about the processing now, the data cleaning, handling of missing values, and things like that. Then you can do feature engineering, you want to extract features, then you're preparing and building, then development. So you can see that it's like a module. So there's a module before another module, like the way we were programming before. Now we are programming in packages.
Yes, sir.
Packages. We are programming in section by section. Let me use the word section by section, so that our section by section, so that our code, our machine can be much more handled. So that now, the way it is now when you work with enterprise is that, like on before, like the one I told us to do in the beginning, we saw that you're the one that handled all the things. You're the one that got your data yourself.
Yes,
you're the one that cleaned your data yourself. You're the one that did your processing yourself. But in this case now, when it comes to enterprise machine learning, there is a team for each stage. A team. So the people are working in teams. So there's no one-man work here. The ingestion and validation teams, they are on their own. So what they do is that they make sure that before the data goes to the processing and feature engineering team, the data is well ingested, is validated. And what is validation again? Is this data useful for the people that need it? So you know, how would I call it? You can get data, and the data is not useful for anything. And,
yes,
and it does not meet the goals and the objectives of your company. So why use the data? So that's what they do. That's their work. They check what is the relevance of this data. Then they go to the next stage, which is the processing and feature engineering. Then I look at it. Okay, what are the impurities in this data? What are missing values, or what are the features? Then the extra features. The extra features. When you talk about features, what are those key predictors exactly that your model, they are called key predictors. When you talk of features, what are those predictors that make your model work better when they are trained on those particular features? When you move into the training, so there's a training in this department. There's training, and evaluation. So they now build a system. So before they do that, they keep on retraining so that the system learns better. They get external data. So it's like a continuous system. So you see that things keep coming from here, going this way. So they keep giving them raw data to check. Then after they've done that, they retrain model. You know, they've already trained the model before. Now the retrained model again is now sold to the deployment and serving now. That is where deployment people comes in now. The deployment engineer, we call them DevOps and the MLOps engineer. So they begin to look at it. Okay, how is this system? How viable is it for user? Is it user friendly? Is it user compatible? And things like that. Then we go into the monitoring team. So these are the guys that mark and they track performance of the system. The system actually doing what we need it to do after it has been deployed. So they are the ones that get feedback from customer. No, your system is hanging now. So you see now, immediately there's a problem here. You can see model feedback loop. Immediately there's a problem in monitoring and performance. They send it back again. They begin to retrain the system based on the complaints that the user has made. So this is what it's not a simple scale. This is what your enterprise and machine learning architecture looks like. All right. So what is enterprise machine learning? I said it refers to large-scale application of machine learning across an organization to drive business decisions, automate processes, and create a data-driven product. I don't know if you're in my my webinar that we did, the cybersecurity webinar, when I was talking about transforming businesses through automated operations. So now we are talking about that. Now that's what enterprise machine learning has to do. So it involves those things I told you about: building, deploying, and managing ML models efficiently within enterprise environment. When we talk about enterprise environment, we're talking about company environment. Is it a finance organization? Is it an health organization? this is an agricultural organization, so this is an enterprise environment now. So it means that the model has been connected to a database that collects information, processes the information, and gives out the required output. And there's monitoring behind security and all those ethical issues, all behind it. So it's just building, deploying, and managing ML models efficiently within enterprise environment. Okay, so look at it now. Let's simplify. Because that's one of the things I think it helps us out. But that's just big English at that end here. So it's just big grammar we're talking about. So what's the bigger picture? What are we talking about when we talk about enterprise ML? First, it helps businesses use data and machine learning models to make better decisions and improve their business processes. That's what we are trying to do. That's what enterprise machine learning is all for. It's for organizations to be able to use the data they have gotten, either finance data they use to counter fraud or anything, with machine learning model that has been built by data scientists to make better decisions and improve their processes. Then it involves the use of large data sets now. Unlike when we were doing our beginners and everything, people were using data sets of 640 something. Now when you're talking of enterprise, I'm talking of data sets of 500,000. In fact, from a million data sets, because you are working, companies may have branches. Just imagine you have a company and your company has branches all over Nigeria, specific. And for all your states, you have at least, let's say you have at least 10,000 customers. To multiply that by that, it means that you have 360,000 customers. So large data sets works with very big amounts of collect from different sources based on on your enterprise. Then it deals with team collaboration. You know, I told you, it's beyond just one person managing a system now. There are teams for each stages, each module. So that's why it's called modular programming. Each modular pipeline. So it involves many teams of data scientists, engineers, IT experts working together. Not just IT experts, you have business experts also, sales experts, customer relationship experts, because at the end of the day, you are building a system that users are using. So you are not the one using the system. There's an end product, there's an end user that will actually come on those systems. So you need a team. Then deployment pipeline. Models are tested and automatically deployed to real world systems. Yes. It's beyond that one that I just told you deploy using Flask. This one now you are creating a system or a model or a machine that people can use in real world situation. Then it calls for integration. When I talk about machine learning operation, it combines data engineering, machine learning, and DevOps to make the ML process faster, more reliable, and easy to manage. So you need all these people from diverse fields. Later on, you'll be seeing the meaning of ML ops and machine and DevOps. So what is our overall goal when we're talking of enterprise machine learning? What is our overall goal? We want to make machine learning solution scalable, efficient, and useful across the whole workforce organization. So we're not just talking about just the department now. Can we create a system that the whole organization can benefit from and use from? But it's scalable, it's efficient, it's error-free, it's effective for their usage. So that is what we are actually talking about. All right, so let's go on. So, like I said, ML ops, talking about those terminologies. So it's better to simplify them now before we go in. That it's called machine learning operations. It's just a set of practices that combine machine learning, data engineering, and operations to manage the entire ML lifecycle, from data preparation and data training to deployment and monitoring. Now you need all forms of practices now when it comes to building a modular or a pipeline. So you need data science experience. You need engineering experience. You need operation managers. Pipelining. They are good with pipelining. Okay, from what stage does the project go from that? So you need a lot of to manage the entire machine learning life cycle. What is our goal? We just want to make sure that our machine learning It's easy to build our models. It's safe and easy to build model, easy to deploy and maintain at a large scale. At a large scale. So just beyond, building a small scale that I'm building on my system. Now we are talking of several servers, network servers, Windows servers, database servers, class servers are involved, which we call a federated learning. A lot of things are involved when it comes to that. Then when you talk of DevOps, development operations, it's also a set of practices that bring together software development and IT operations teams to work collaboratively. So anytime you hear DevOps is a combination of IT operations and software developers. You bring them together to work in a team. Okay. So IT operations are the ones that do the syntaxes. Oh, this is what is supposed to be here. No, this is not supposed to be here. The software developers are the ones that now give us what the product that we need. Why do we need this combination? We want to speed up software development, improve the quality of our model, ensure continuous delivery and integration of the software system. So IT guys cannot do it alone now. When we start talking about enterprise and the last scale, you cannot work alone now. You need to work like there's a work now. My work that won award in last week about 2 years ago. The engineering guys in last week called me about. I think we met. Okay, no, we met in August. They are telling me that they want to develop my software. They want to make my software into a device. So we need to meet and talk more about it. So that's what we're talking about. So I'm going to be doing that now. I'm going to be meeting guys from engineering, going to be meeting guys from software development, data scientists, health guys, because I'm working with health data. So we're going to be doing a radiology. So imagine creating a chain from so that is just it. So what are the challenges that you face when you want to scale your MS system? You are trying to bring it into a bigger picture. There's always bound to be challenging because number one is data inconsistency. Data used for training and testing may not match or may change over time, leading to unreliable model performance. Yes, data changes. Just like look at us now in the health sector. There's one of my paper that I wrote now. I have to rewrite it. When I wrote the paper, it was fantastic. But now I have to rewrite because there's a new development in sickle cell anemia, which was not included in that paper. So now I have to do like an upgrade of that paper. So I was told to review the experiment, adding some feature selection techniques and putting some things into configuration. So things change. So when it changes, how do you, so these are the things we must put at the back of our mind. Then there's the issue of model drift. What is model drift? Models accuracy may decrease because of real-time data changes from what it was originally trained on. Yes, you might train on Google, I've gotten 500,000 data sets. Well, when you not get to your field there and you're not getting real-time data, there's the probability that the model accuracy will decrease. But it's not a cause for alarm. All you need to do is go back with those data that you've gotten now and go and retrain. So, and that's why you see that the system must be, when I showed you that architecture, you could see that it was saying training, retraining. So you keep on retraining, so the system keeps learning and learning and learning every time. So that is one of the major things that you see about it. So the issue of what you call the model gist. All right, so then you have what you call deployment bottleneck. This one is always very common. Deployment bottleneck. You have deployment bottleneck. What is deployment bottleneck? There's always delays and difficulties that occur when you are moving modules from development stage to production. Yes, because you have to carry along all stakeholders. We're talking of everybody, for the people who are funding the project and those that will use the project have to be carried along. So it can be some bottleneck, but it's not a problem. Then there's always this issue of lack of version control. People don't properly track their data code or model version. It is hard to reproduce or update your password. And that's why we are learning. You see that we are talking about modular programming. You see at the end of this class, we'll be talking about versioning and things like that. And we start our practical, we start teaching you how to do versioning, how to save your work, commit your work, and things like that. Start to learn commit statements and a lot of things like that. So these are just the two challenges that you see. All right. So what is the core goal Apart from we talked about the challenges, but no matter how the challenges are, there are fantastic benefits of this. And the goal is that number one, scalability. The system must handle or growing amounts of data. Users and models without performance issues. Yes, these are the core goals to put in mind. You can put those goals in mind. These challenges will not come. Because you hardly have challenges. So number one, your system must be scalable. So you must be able to handle what changes because the system keeps growing. When you started your company, you might just be 5 of you that started the company when you guys started. But after today now, you might be about 50. Was it the policies you were using when you were 5 that you used for 50 now? No. Maybe when you started at 5, there was no issue for conflict resolution. But now that you have 50 diverse number of people, you might need conflict resolution. So you might need to get what counselor or somebody or something. And you guys are becoming 500. A lot of things coming on. So the system must get to that stage where it's scalable. That's our goal. Then it must be reproducible. In fact, that's one of the things we keep learning now in machine learning. And I think I'm one of the advocates, and I've been called me severally now, almost like 3 places to come and talk about reproducible research. The experiment and results should be easy to repeat using the same data code and settings. I'm telling you, if I create a system, and that was what if you notice for those of us that did the USA. Some people called me and said, sir, I did the work, the mark you gave me, I was laughing. And I told them, I said, okay, let me schedule a meeting with you. So I took their codes and everything, give it to me. Let me run it. By the time I run, I was getting something different for what you got. It's impossible. If there's going to be slight changes, it should be in the point of 0.05. There shouldn't be so much, gap that it now looks like what happened. If you tailor your model and things like that, so it must be what reproducible. Then it must be maintainable. So maintainability must be in our apps. That's the core value or the core goals. Models and systems should be easy to update, keep and improve over time. In fact, that's why we are doing all this modular. When it comes to advanced, everything we are doing and in advance is what how to make sure that somebody can reuse our code, somebody can get to your code in your model or your model and be able to adjust some problem or be able to update. So you must give allowance for update, fix and improve your model over time. If you notice that's why you notice that our Android systems and things, for every time you come, you see sometimes you just the update comes and says version, this is bug or something, this is something like that. So there has to be what allowance for that. Then automation is our goal. Tasks such as data processing, model training and deployment should run automatically with minimal human effort. Yes, we don't want to be going back and doing processing ourselves. When we get data now, we should have automated the system up to an extent whereby when new data comes in, all it does is it knows what procedure she uses in the data processing. Train the model based on the algorithms that we have created, then deploy. But when it comes to that deploy, there has to be guidance also. But sometimes you might deploy and you might not fit what you need for. So things like that. Then the issue of security. You must protect data. But ethical issues in machine learning now is becoming very, 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 the light of the law is being shone on it now. So you need to be very careful. Your models, your systems, some unauthorized access and ensure compliance with privacy risk. Yesterday we were talking about when I was teaching the Islamic class, and we were talking about issues of when you are writing your modular code. So you also do modular code, but at a very low level, not like what you will be doing. You are talking of issue of encapsulation, abstraction, and those kind of things. How do I keep a code? And instead of me saying 15 lines of my code, I can use one line to render that 15 lines of my code. So these are things we'll be looking at as we go on. Okay, so that brings it to the end of what enterprise. So what is ML architecture itself? This machine learning architecture that we want to use for our enterprise machine learning. This is what it looks like. So you have your generic ML. So I call it a generic ML architecture. So you can see the user through your web application. They are the end user. So you can see the data scientists who are training. So we should have statisticians here, app engineers here who are, so they input their query. Query comes into they input their query. So the query comes, if there's a direct answer, it comes to the model. But first, the initial one first being trained by the what? By the data scientist, goes into the algorithm, then into the model, then there's an output. Subsequently, when the user comes and it gives a query that you have already trained, it doesn't come to training of data again. It comes here and just comes to the model and gives an output. But if the user inputs a new query or a new data, it comes here and trains itself from that data, uses the algorithmic solution, give the model the answer, then the model feeds back for the prediction. This is just what the ML architecture looks like. So users must be able to come and say, just like your ChatGPT. You come into your ChatGPT and you ask ChatGPT, what is machine learning? It goes back because it has been trained on machine learning. It tells you, goes to the model and gives you prediction. There are times, I don't know if you have queried ChatGPT. He's telling you thinking for 5 seconds. So have you done that before? Have you noticed it?
Hallucination.
Exactly. He's thinking, telling you I'm thinking.
Yes.
It hasn't seen that data before, sir. So what it does is that at that moment he's telling you he's thinking. He's taking the data to here, prompting the data scientist to say, I've not seen this kind of data before. So they begin to run a training automatically. The training runs to say, okay, let me quickly, go to other database and see what is this person asking for. And if you're not careful, sir, because it doesn't have that trained data, it might hallucinate and give you something that you don't need. So that's just the way the generic ML architecture looks like. All right. So when I'm talking about, or when we are talking of ML architecture, we're just simply talking about the blueprint that shows how machine learning systems are built. That's just it. How did you build your system? How did you train it? How are you deploying? And how are you what? How are you monitoring? So the blueprint is just as simple as when you are also, how would I put it? When you want to build a house, there has to be a plan, sir. Architectural plan for building a house. You don't just wake up one morning and just buy cement, buy blocks, and begin to arrange. It's not possible. The house will collapse. The house has to start from, okay, the soil texture is a test it. This place is a swampy area. Is it a waterlogged area? Is it a sandy? So those are the things. Just a blueprint. Shows everything. What is the purpose? Help us to organize our machine learning workflow from data collection to model maintenance. Just like what I've said. There has to be a blueprint. There has to be a plan for building. Nobody just wakes up one morning and say, I want to build 4-story building here. Have you done the necessary things that should be done? So those are those things we talk about when it comes to model machine learning and architecture. All right. Then look at the typical machine learning architecture layer. Start from data injection. So your feature engineering, under your feature engineering, you have things like feature selection. Then you have your model training. Under your model training, you have your data feed. You could do some hyperparameter tuning. A lot of things are underneath them, but these are the cases that cover them. Then your model development. Then you now monitor. On no account must one deploy a model that you will not monitor and get feedback from. Then there's no need deploying a model. You can just stop at training. If I'm going to deploy a model and you're not going to be monitoring it. I was trying to go through somebody's website yesterday. He created a very beautiful app. I got there, told me the app has been sleeping for too long. It means that he has not been monitoring, he has not been going there to update versions. If your users are not even, if there are no users, keep updating versions so that you keep keep the model alive. All right. All right. So we just spoke about the layer. So I said on no account must you deploy a model that you will not monitor. All right. So what is the description? I wanted to talk about those layers. We've just been talking about them in the same picture. So what are those layers? When we talk about data ingestion, you see, when it comes to just natural machine learning, we talk about data collection or data gathering. But when it comes to my ML architecture, we call it data injection. Because now you are not only collecting the data, you are also importing those data from different sources. So it goes beyond the collection. As the data is coming, it's being imported into the system. So it's called data injection. So when we are talking of ML on enterprise page, we are no more talking of data gathering or data collection anymore. It becomes of data injection. So when we now talk of feature engineering, when we talk of feature engineering, now you begin to do your cleaning, your transformation, your selecting an important data feature. So that's where your pre-processing comes in. Things like normalization, data augmentation, data resizing, and a lot of things. You drop missing rows, you clean data for null values, and things like that. So feature engineering now comes in because now it's deeper. So because why is it called engineering now? The kind of programming created. Now you're not just dealing with 600 data sets. So you might be able to do so. You now create like a code that can handle larger set of what? Okay, large set of data. Then you go to our model training. So you now use your data to teach the algorithm how to make a prediction. And this is something that we have done. So we know how to use our data now to teach our algorithm based on which algorithms are using. Are using the machine learning algorithms or we are using what? Deep learning models. Then you now deploy your model deployment. You are making the trained model available for what? Real world use. You want to see, okay, I've even built this system to detect the advantages. If I throw it out there, can we actually do the work? Then tracking and what? And feedback. You're not tracking your model. Okay, is it working the way you want it to work? If it's not working this, okay, let's go back again and go back to this model training and what? Improve what? It with a new data. So that's what you keep doing. So the process is like a life cycle. It's like a life cycle. But what? Monitoring and feedback. So you're tracking your model performance and you're improving it with a new data. So those are what the ML architecture layer, that's what each layer does. All right. So what are the key components of what a scalable machine learning system? Number one, the first thing you need is a warehouse. When I talk about warehouse, we talk about a central storage for both your structured and unstructured data. So you must have what? You must have a warehouse. The warehouse is just like a data storage where you are storing your, but when your data becomes large and beyond, it becomes a warehouse, so you are housing different types of data. So it becomes more than a data storage. Now it becomes a data warehouse where you have a diverse number of diverse quantity of diverse repository of data. Then you have your feature store. The feature store. This is a repository to manage and use features for your model. You must have that. I told you when you talk of features, you are extracting what? Key predictors that gives your model better performance. So when you see some key predictors, you have to reference them and store them. So for any time your model is picking those data that keep coming in, immediately it doesn't notice that predictor. It knows that, okay, this data might not be used for this. It shows those data. So it attracts the data that what has those key predictors and uses them for what? For your model building. Then you have model registry. You must have a system to store your model, to track and manage your model version. Yes, like what I was saying, you must manage version. That's where versioning comes in. Okay, when we started with old version 1.0. Now we're in version 5. Then somebody might come and the manager might come and say, okay, why did we just move from 1 or 4? 4 did not spend more than 6 months. You can go back and track and say, we are using 4, but we noticed something about 4. Version 4. And that was why we had to quickly upgrade and work on it and move to version 5. Then you have what you call your CI, CD, or orchestration. So these are tools. These are component tools that you use for building for automating your model building, testing, and deployment. When we're using the local ones, we have things like what's it called? A Flask. That's the Flask. But now we're looking for enterprise. We have what we call the Airflow, ML flow, and the Kube flow. And people say it's Kube flow. It's not Kube flow, it's Kube flow. The Kube flow for what? The model development. So these are some components and things that you need to have at hand. All right. So common tools now. I want to explain those tools. Like your Airflow now. It automates your workflow and manages your data pipeline. So Airflow manages your data pipeline. Your data are well structured, they are well arranged. No matter the amount of data set that is coming in, they are they are well managed, the workflow of the data. Then it lets you to know, okay, this data has been used before. This data was introduced at a particular time. Now we have introduced a new data. This data was changed on a number of times and things like that. Then you have your machine learning flow, which is the ML flow. This manages your machine learning cycle. You know, your machine learning cycle is that full cycle from data injection to your feature engineering, to your model training, to deployment, and so it manages that. So it includes your tracking, packaging, and development. So it manages the major flow of your machine learning. Then you have what you call the Docker. Docker is a container application that what ensures consistency across different environments. Yes. When you talk about Dockerization, people say Docker is like you are packaging your system web there, your model, so that you can use them on different platforms. If you're looking at that, so I can containerize my application and make sure that it can work on all different environments. So we'll be looking at that also. Then there's the Kubernetes or the Kubeflow. It orchestrates and manages containers at scale for development and scaling. So for your Docker, the Kubernetes helps you to manage what your Docker or your containerized application. Then you have the scikit-learn. So this scikit-learn is a framework. You'll be seeing that so much in when we are working on, we are doing our practicals, because we'll be using our local, so you'll be seeing scikit-learn. It's a framework for building and training traditional machine learning models. So when it comes to using machine learning models like your FGM, your random forest, logistic regression, we use the scikit-learn. Then when we are moving into deep learning framework, we use what we call the tensor flow. So you remember when we call our libraries, we want to call our libraries and things like that. So when you are working with machine learning models, you use your scikit-learn. So when it comes to deep learning models that have to do with images, they're trying to work on images and things, you use what we call the tensor flow, which uses neural networks to work. All right. So what are the best practices when you are carrying out your enterprise, or you are trying to set up your enterprise system? The first thing was a modular design. You know, I told you, I said breaking systems into reusable and independent parts. I told you breaking them into sections. Section A, section B, section C. So that's the word of modular. They're just breaking it so that I can come in and we are building a new system, sir. And all we need is that we don't need to rewrite section A for the new system. We just come into the old system and take the section A or copy and paste it into the new system. So if you notice when they do version of things, somebody was telling me, yeah, I just updated the version of my OS. Nothing really changed. It's a lie, something changed. Something changed. The engineers have done something, but the reason why you will not know is because they did not rewrite the system. So that's one good thing about this enterprise pipelining. You don't rewrite the system all over again. All you do is that you just remove the part that is giving problem. Or maybe from the part that's giving problem, a line that's giving problem. You expunge it and put a new line. So you won't know. Somebody will say, no, it's not there, nothing was done. No, something has been done. You see them when you go and check version, you say fixes bug or find something. And I think one of the problems we have in Africa on the lighter mode is that we don't read. We don't read. Before I install version, I check them and say, what's there? Like yesterday now, I was in my class and my Mac OS said they wanted to update my Mac OS. I was like, I updated 2 weeks ago. So when they said I updated 2 weeks ago, I now noticed I've been complaining about my battery not charging properly. So I saw that it was an error from them. So they put it there now, unstable battery charging or something like that. I tell your battery to show the thunder sign when it's charging. It keeps on showing that it's plugged in was not charging. So it was an error from the version that they actually brought out 2 weeks ago. So they corrected that. But if I've not read, because nothing changed actually, I didn't see anything. But the only one, because I read, by the time I plug my laptop, I can see the thunder sign now back. Not before where you have the plug things what it is not charging. Then you must have what? A centralized versioning. Versioning is just tracking your changes. So when you are saving, one of these great problems is that I don't know, Africa, God will help us in Africa. A lot of things are just done without a processes. Like when you're writing a document, sir, the normal process of writing a document is if I send you a document for you to write, when you are writing the first one, you don't come and overwrite it when I say there's a mistake. What you should do is that you save the first one for the mistake where you made mistake, copy and paste and correct and call. So version is like creating documents and saying this is the first document I just created, version 1. Okay, let me use an example of version now. Like when we are writing our journal, there's something our prof does with us. When you write a journal and you are submitting, we tell you to put in front of it first draft. And when you are sending the first draft to him, you save that first draft. When he's sending you correction for first draft, you don't delete the first draft that you made correction on. You duplicate the first draft, make the corrections on it, and call that one draft 2 and send to him. If there's another, so that in case there's something that it was vital during the process of all right.
Yes, sir. Yes, sir.
All right. So that's what versioning looks like. You keep saving your version based on your correction. Then I talked about a containerized execution. Use containers, which are called Docker, for portable and reliability. So when you see all those apps that you download, and you see them saying download app, that's what they've done. They Dockerize the app. You see that there are some applications that you need to do, how would I call it? You need to download and do a lot of installation. But you just see some apps, they call them portable apps. You Dockerize them. All you need to do is just copy them and paste, and it's working on your system. So it's always good when you use containers. It's for portability and reliability. Then there's continuous integration. You must do continuous integration. Automate your testing, deployment to ensure quality and consistency. Everything you do must be automated. No matter how little it is, even to the process of report writing. You must use your doc string files or your doc string files. So you must document also. You must be automated. All right. So this brings us to what modular pipelines now. We have talked about the enterprise, we have talked about the ML architecture. Now, how do we do the sectional pipeline to come to modular pipeline? All right, this is what your modular pipeline is like. Now, I'm telling you that for all those stages, there are a lot of things going on in it. Look at for the ingestion. When you come to ingestion, you can see that it is your.
Yes, sir.
So, like I told you, a lot of things are going behind the scenes. Look at the injection. Your system must be able to first receive any format, any data format. It shouldn't be restricted. Not just CSVs alone, HDF, DICOM, Avro, JSON, whatever they are coming from. Must be able to. Then you can see something called disparate and time varying. You must be able to tell us at what time this is a particular data coming. Is this a real-time data that is just coming on, the ones that have been set for processing, for batch processing? Then you check out data integrity and the security of the data. Is this the data that we hope is not the data coming in to come and to intrude our system? So you see data processing now, you can see a lot of libraries to use for your pipeline kit. You are working on your machine learning, you have your scikit-learn. You are working on your deep learning, you have your TensorFlow. What's going on here? The data is being visualized for. What kind of data is it? A lot of EDA is carried out on the data set to be sure what are the issues with the data. Then there's feature transformation and engineering. Then there's pipelining for those data sets before it goes into model training. So there's a cross validation. The models are selected. So the workflow within workflow. So a lot of things. Then your pipeline, you can see your final pipeline in here. When you talk about final model now, they are talking about both your deployment, everything. Training, for consistency, prediction, inspection, interpretation. It's like, it's a body, a whole lot of body that. So you realize now when I told you that for an enterprise ML system, you need teams. So just a person cannot do all this. So you need what? You need a team that will be handling the injection, those that will be handling processing, and those that will be handling what? Model training and deployment, and then going towards feedback, monitoring and feedback. Okay, so modular pipelines are machine learning workflows that are divided into independent, reusable components. Allow each step of process in the process to be developed, tested, and maintained separately. So you are doing that now. Like when I was teaching us, or Mr. Blessing was teaching us, if you remember, Mr. Blessing tells you that before you start, every library you need, import your library for.
Yes, sir.
So that's like an example of a modularization in a very smaller way. Call all your libraries first. Then next, define all your functions. Function for taking in data, function for data processing, function for model training, function for what's it called? Plotting of tasks and things like that. So each process can work on their own independently. So when you now bring them together, it becomes what? A complete pipeline. So that's what we are working, we are trying to talk about when we talk about modular pipeline. So why modular pipeline? Why? These are things you keep saying. You keep on seeing that from enterprise to ML, all of them have what? Number one is always what? Maintainability. You know, they are easier to update and manage because each component can be what? Modified independently. You know, I was telling you, when you have modular like that now, just imagine you have 10,000 code scripts and it gives an error. How do you read where the error is from? It will be so very taxing. You get me now? Very taxing to go and check for error. But when you build a modular pipeline, importing library on its own. So when you call, it tells you immediately, no, the problem is from library importation or from data importation or from data processing or from training. So we talk about the error management and things like that, which I was also teaching. Also, we are also talk about managing errors. You set error messages for yourself. So when something goes wrong, it doesn't just terminate the whole process. It tells you where the issue is from, so you can quickly go there and stop that issue. Then you have parallel development. Different teams or developer can work. You see what I told you. So we don't have to wait for Mr. Lajini, have you not done your work? I'm waiting for Mr. Shegun. Mr. Shegun has not finished the part of the data process. That's why I've not changed. All of us are working, so at the speed, at the same time, at the same speed. We are all working together. There's a different team handling that. So that's one good thing about what modular pipeline is. Then you can use code reuse. You know, I told us we want to build a new system, and we realize that what we need from the new system, we have some of the components in the old system. We just go there and pick them and put it in. We don't need somebody to start developing those parts again. They can be used in other projects without rebuilding the entire pipeline. Can you see? We just pick what we need. There are times that the only thing that might change is just a part of maybe processing based on the kind of data set that is coming in. That's just it, most of the time. Or we are trying to deploy using another kind of format. We don't want to use Flask to deploy. We want to use another form of deployment. It's different. So you see, but we are all working with parallel. There's easier testing and debugging, yes, because the modules are separate. Errors can be identified and fixed separately. Like I told you, you can fix error easily. You don't need to say, God, 10,000 lines of code. Where do I start from? Imagine when it tells you have 10,000 lines of code and they tell you error is in line 10,000, is in line 7,000. You're already laughing. It's in line 7,000. How do you want to start that? 10,000 lines of code. You want to go and start for line 7,355. You will leave the work and say tomorrow. So,
Yes.
so that's just it. That's it. There's flexibility. Teams can update or replace one module. That affects, yes. Oh, when you did your processing, we don't like that side. You can just go remove it and put the new reprocessing pipeline straight. It's just like when we are connecting water pipelines. We are connecting, or let me use this petroleum. You see that for every 50 meters, we have a ring that connects two pipes together. Like in case there's a damage somewhere, you don't need to stop the flow. All they need to do is isolate the area that there's damage and bring in another pipe in.
Yes, sir.
Just fix it. So that's what we are also doing, sir, for our building our modular pipeline. There's scalability, as I said. The make it easier to manage and expand complex LMS systems as you grow. There's no every company wants growth. We all want growth. So we won't say because our customers are growing, then you must grow. So you must leave room for what? Expansion. What kind of expansion? A new model might come out and is working better that you want to include into your model training that it will help your system perform better. So you must create functions that allows you to add more than sometimes some writing or programming are rigid. Some building are rigid that I've seen somebody that built his house. The way he built his law, nobody knew that he wanted to build duplex. Put roof. He now told us that when he would build it, the idea was to build a duplex, but at that time they didn't have the money. So when they came, they said, no, they have to come in, structure something. When they got there, the engineers could not do anything. What we had on ground was structure to even carry 2 more buildings.
Wow.
So he had already was giving room for expansion. Give room for expansion. So that's what scalability comes to. Then there's collaboration. There's teamwork. So you can work with different team members to work on a specific pipeline independently. All of you are working on different things, but all of you are saying the same thing. The guys that are handling input, the guys that are handling processing. So you see a lot of. So at the end of the day, you find out that you are just vast in all areas. You guys are working independently, but as a team. Teams working independently, but in larger teams. So it's just a very good. And that's why you see when you see these our white people just aside, as I'm saying, just to say something like that. People say, there's no job in Nigeria. The problem is that we don't create work that create jobs for us. You find out that in the department, exactly, so they don't create. These are foreign people. They are so smart enough that you find out that in just a particular unit, they are separate departments, people doing different things, and they are working effectively. For Africa, we want Mr. Shegun and Mr. Dide, Mr. Wale to do 15 people's work together. We are paying them. We are paying you for it now. So that's why we will not work Monday to Sunday. So those things. It's the truth. So those are the things that we see. All right, let's go on, sir. The modular pipeline stages. I tell you, we keep on talking about those stages. So you see that from the enterprise and everything, they all have the same stages. But we always talk about data injection. Now you are seeing that for the pipeline now. But before we didn't talk about evaluation. Now evaluation has come in before deployment. So you have data injection that you have known. You have pre-processing. You have feature engineering. You have your training. Now evaluation comes in. You must train. Must test the model performance using metrics to ensure what accuracy and reliability. Then we've spoken about deployment before. So when you look at them, you just see that they are different, just some things. So that's why when that comes together, when all of them come together and work together from enterprise to ML architecture and modular pipeline, it forms a complete one, a complete scalable system that is usable. All right. So what are modular tools? So these are the tools I was telling us about. You see something like your cyclic lens, you see your cyclic image, you see your tensor flow, your hook flow. Central, yes, Central is a part of them also. So these are tools that we'll be exploring. But we'll first start with our cyclic lens and tensor flow first. Since we have those ones readily available on our Conda and digital lab. Then as we go on in the class, we'll be moving to hook flow and Central. Right. Data versioning. I told us it's not enough alone. We are going to be speaking about versioning concept. You must save what stages of your data so that you know what did you remove, what did you expunge, what did you omit, what did you not put into training and things like that. All right, look at it now. Can you see? There's this loop here.
Yes, sir.
This is what is a continuous process. The continuous process. Configuration comes in, data comes in, code comes in. The process continues to give us a model. So when you do stage 1 of this to give you the first model, you save. When there's an improvement coming in, you don't save it on this model. You save it as a new model, and that's what brings about you seeing that there's always software upgrades, and those software upgrades are called what? Version 3 point something, version 4.9, because from correct corrections have been made in the coding, some corrections have been made in data, or maybe new data has been added, some new configurations have been added, bringing into the model. So you must take every instance. At what instance did we add new features to the code? So you see some version code, you say, or some version number, you see sometimes you see 3.7G or something. So it might be they are talking about code. You see some will say 3.7L or something. They might be talking about data. So depending on how you guys have sat down to say, okay, this is the way we begin our versioning. But every time there's an improvement on our concept. So this is what we just work is all about. So the model, so that we don't just have a model that is rigid. We have a model that can grow over time. You know, that's the reason why we are doing everything about modular and scalability. It's just that we can expand. There's room for expansion. There's room for what? Expansion. All right. So what is decimal expansion? It is the process of tracking and managing changes to data sets over time, just like version control for code. You are managing, you are looking at it, tracking the changes. When we started with 10,000 data sets. The next time we're doing, the data increased to what? 10,000 to 15,000. We must track when the extra 5,000 came in. Exactly. And what are we trying to track here is that when we use 10,000 data sets, what was our model performing like? When we now introduce extra 5,000 to make it 15,000, what is the model performance now? You know, so you can draw insight from that. You say, okay, our model works better when there's larger set of data, or our model underperforms when we introduce. So you now know, okay, we have to go back now and go and work on a model to be able to accept that if there's larger data sets, we should perform better. So you know you can track changes and manage those changes. So that you don't just wake up in the morning and your manager comes in to say, Mr. Shegun, yesterday now when I was saying these things, he was giving me drop out button. What happened today now is not giving drop down button. Maybe by the time you created the first system, you only had 7 data sets and you created only a drop down for 7 data sets. But after the morning overnight, data has been updated to 13. But because you have left capacity for 7, when it kicks, it sees it as an error from the back end and drop down button doesn't work anymore. So that's why you must track and manage changes. So what does data versioning matter? I like talking about so that we know why we are doing that. I said data changes over time. You know, I've said that before. Data is often updated, corrected, or expanded. So versioning helps you to track what these changes over time. Nothing remains constant. Nothing remains constant. Yes, change is only constant. In any other thing, there must be a change. Then, why data versioning? Reproducibility. And you are ensuring that experiments can be repeated using the exact same data set used originally. You can see like that. You know, because by the time there's an upgrade, sir, you have lost the former type of where you started from if you are not careful. But if you keep a version of when you started from, even if they are using a newer version, and somebody comes to say, oh, I want to do a documentary or want to do documentation of how we started, you can go back and call that where you started from.
Yes, sir.
And when they run that code, it still works like when it started. But you're already using a newer version. So it's a very good one. That comes to audit and compliance. That's what I'm talking about. Maintains record of data source and transformation for transparency and what regulation purpose. You see that you are transparent already. Yes, when as you start, we started with 10 data set. Where's the proof? But because you have done versioning, you can bring out proof of where we started from. This is how we do this is where we started from. Then it helps you for rollback and recovery. Just imagine you updated the system and something happens in the cloud and it crashes. If you don't save a version, sir, it means that the whole system has crashed. You have to start from the scratch. So versioning is like a form of documentation. So if it crashes when you are trying to upload the new update, yes, I like what you said. Wow, yes, sir. It crashes and maybe you are trying to do. You know when we do migration now, you are migrating from one.
Yes, sir.
I was telling somebody one day when I was still working before I moved into data science, I used to be a server manager. I was working with Dr. Ben. He was telling me, he said, today I like the way you do things. Anytime we want to do any migrations, I do backup. Even though our boss complains, you are wasting storage. We were doing a major upgrade, sir. I was happy I wasn't discouraged. I did the backup. But most times, sometimes I do backup FITC overnight, sir. It might be 10 hours overnight.
Oh.
So I won't go home. So people get to say, you won't allow us to go home today. Use that. We woke up, they came that morning, I was already went home. I want to have my bath so that I'll eat, then come back and join them by 12. Anytime you work overnight like that, you will resume. I just got a call as I was eating. System has crashed. As you're trying to upload into a new server, everything crashed. Where do we start from this? That they were shouting. I ate my food, sir. I had my bath. I slept for 1 hour. They were calling my phone, put my phone on silent mode. I had backup, sir. So I know what I just had to do was to get here, call up my backup, and we'll walk. So I slept when it was 11:30, because it's not far away from where I was. 11:30. I took my this thing, came out, put on my clothes, and took Okada. Straight. We have cheaper towards at that time before we moved to Yaba, FITC. We have cheaper towards. I just took bike far from Navy road to this far. I just took bike. I got in. They were saying, you are very beautiful. I did not even answer. They were wondering why I wasn't talking. I just got there. Open my drawer because all of us you have a drawer you lock. I brought out the hard drive for the backup. I just removed the hard drive in that system, put it and turn it on. Deciding I was just laughing. I think I told you guys. I told you guys. That month I received bonus I received for that month was over. After this time I was telling you I was 2009. I received bonus of over gave me over 100,000 naira that they gave me. When they were paying my salary. Wow. It was 2009, sir. Over 100,000 as a bonus given to me as bonus and this thing. So those are the things. So that's why versioning you can there's something, anything can happen. Anything can happen. Then experiment tracking. You have to track your progress. When I did 10, like I said, when I did 10 data sets, this was our accuracy was. When we increase, those are the things. So these major reasons, that's why you must what versioning was matters a lot. Matters a lot. Exactly. So what are those tools for versioning? You have DVC. DVC is just your data versioning tool, data version control tools. You have tools like Git. So if your Git helps you to do what? Data versioning. You can integrate it with your ML pipeline. So I'll be showing us how to use. Yeah, now we'll be using GitHub to you have to create a GitHub account. I'll show you how when you're writing your code, how you save, how you call your code, how you do so things like that. So versioning helps you. So it tells you this is version 1. Even though if you don't use these tools, it can be done manually. But manually can be rigorous sometimes. So we need
I have a GitHub account.
Oh, that's fantastic. That's fantastic. So to be able to use the back end and do a lot of versioning. Then I will also recommend site to you where you can also do your versioning. Then you have your Airflow. Airflow is for what? It tracks your experiment, your model plus your data. Then you have your Git LFS for large file storage. It works with code repositories. All these ones are for big code repositories where they have large number. But for you and I, Git is enough for us. And use our Git for our versioning and we are good to go. So these are the little tools that we have. So I just spoke about it, using DVC for data management. It's a tool that helps you track and manage your data set and machine learning model. Just like Git does for what? For code. So Git is for code. DVC is for what? It's for data. So in this course, I'll be showing you both code. I will use Git, then we'll use DVC. So we can both Git and DVC. So it enables data versioning for the reproducibility, which we talk about. and collaboration in LMS projects. If you keep on saying the word, the reproducibility coming up, collaboration coming up, scalability and things like that. All right, look at the code for DVC. For DVC, you can see now. If it was for your code, this would be Git init. But for DVC, we are talking about data. So you call your data, see your data file, you say Git init. So it initializes DVC in your project. So when I say DVC add data slash name of your data, it tracks your data set with DVC. So when I use Git to add the data, so you add the DVC metadata to a Git file. The Git story. So when you want to update, we use the word update. So these are codes you and I will be using. Sir, may I ask, are you using a Microsoft or a MacBook, sir?
Microsoft.
Yeah, okay, no problem. Then we'll just install Git. We'll install Git bash onto your system. It's fine. So you can still work very fine.
Okay, sir.
So this is just an example code of what the way DVC looks like. You can see that it's just like simple English. The only thing that don't just forget your commands. That's one thing with Python, and that's why you see that we love Python so much. It's like you're writing English. And you don't need to be writing from comma, exclamation. No. It's like simple English and you are good to go. Then how does it work? So your DVC tracks your large data types and models outside of Git. It stores only the lightweight metadata. What is metadata? It stores those what you need from your. It doesn't store just the complete. It's not too heavy. And stores it into your DVC or repository. So Git now manages your code and metadata, while the DVC manages your data and the model. They keep the two of them in. So anytime you upload anything and you put a new code, it saves it automatically. Anytime you enter a new data set, it does that. So that's what they do. So we say I will initialize our Git, initialize our DVC. I think together they make it to reproduce, experiment, and share. So, and that's why when I write journals now, people get crazy. Send your code. People will say, why are they asking me to send my code? What kind of nonsense is that? I'm not scared. I'm not scared because I have the version of my. So, but you see, people say, why can they ask me? You're telling me that they don't trust me. I say, it's not the issue of trust. That's what is called reproducible research. Somebody wants to be able to get your code and data and make sure that they can also do the same thing using that code and data. As simple as that. As simple as that. So now let's look at our scikit-learn pipeline plus custom transformer. I'm almost getting to the end. So these are something that we're capitalizing with our data set that we have. So look at it. So we have our data storage. We track our DVC. You know that DVC that tracks your data. So your Git tracks your code, your C organization. So you and I we are going to be creating like a repository. So we'll use that now. We'll be tracking our work. We'll be working together. So the practical is going to take that kind of form. So at any changes I make, you'll be seeing it. Any changes you make, both of us will be seeing it. So this is just like a workflow of what your scikit-learn and transformer looks like. From data, so we have our data stored somewhere. So this DVC tracks our data changes. Git tracks what both the data changes and the code changes. Then we can manage more things. So you remember, when you do what's it called? Google Doc. You know you can share your doc on Google.
Yes, sir.
So something like that too. So like when we do Excel, we have an Excel sheet that we need to improve something. So I share with yourself, myself, and one other person. So when changes come in, see if you are the creator of that form, it notifies you to say, well, somebody has just made what? We change. Exactly. So you see that our data in that case, we have our data, we can track our data, we can track changes, and we can work, more than 3 of us can work on the same work, on the same document. So that's the same thing we are doing in our pipeline. Okay. So what is scikit-learn pipeline? I said it's a sequentially chain preprocessing and model set. Sequential. So like what I showed you there. Sequential from one step to the other. Exactly. One step to another. Sequence by sequence. You are working as a team, but no, everybody works independently then before we come together. So if one has problem, it doesn't affect the work of the other person. All we need to do is quickly correct where the problem is then we go on. Then what it ensures what? Consistent transformation. Yes. People just realize that when you work on a pipeline, you notice that you wake up in the morning, your interface was looking a bit funny. Then the next day, your interface has changed, or your web interface has changed. So those are the steps. All right, so more details. I just want to explain that more. What's the purpose of this? Why are we doing scikit-learn plus transformer? What's the purpose? We want to create a streamlined workflow by chaining multiple steps together. Now we are not creating what? Pipelining. Now we are building scikit-learn. We want to do what? Call our libraries, call our data processing procedure, call our training procedure, call our model procedure, call our deployment procedure, call our result procedure, call our evaluation metric procedure. So it's like a chain. You know that when we are streamlining workflow by chaining multiple together, every chain has a link to where it's connected. So if there's a bad chain, you can remove where the bad chain is and link back again. All we just do is remove the chain that is broken and link back, or replace it with another one, and the work continues. We don't have to go and buy a new chain all over from the beginning again. So that's what we're trying to do. Therefore, functionality, we are sequentially linking processes. So we are scaling our encoding and our model training steps into a single object. Exactly. So everything will now be like, we have this phone, this phone now, everything that we have done, section by section is in a container. It's like we have containerized it, like I told you, Docker. Exactly. So when we don't fix it and run it, we start from the beginning and do all processes. Without having to initialize from training to we are putting into a container. Then there's consistency. We ensure that the same data transformation are applied during both chains. Yeah, exactly. I saw when I was working projects, somebody already he did EDA or some data set. He did some cleaning. Because he did not use pipelining, he didn't know what to do again. After he had done cleaning of the data very well, all he had just done was that in the code where he was writing there, write the data, then tell your code where you are initializing that the new data that has been cleaned, save it now as .clean.csv. Then you'll have written a function that now after .csv, clean.csv has been saved. The system training will now use, the model will now use the new data that has been cleaned to train. You not train on data that he did not clean, because he didn't understand how to bring it out. And that's why you see that it's good to work in a team. If he was working in a team, that would have been the work of somebody else. He has done the EDA perfectly. He has done his part perfectly, processing and everything. But he didn't understand the training part, and that's why you must have a training team. So imagine if that work was done on a large scale, you know that he has messed up big time. But because I saw that he had the idea of what he wanted to do, I had to give him some mark also. He did a very fantastic job from calling libraries, they were sequential, they were modular. But when he got to that place, everything got modeled up. So when he was getting, I remember I kept on calling him, accuracy was not good. And I was wondering what did he do. So when I saw what he did, I said, no wonder. You can't have a good accuracy in what you have done. So then the advantage is that it uses code repetition. Hey, that's it. Human error, that he was facing human error. If he had just done that and put in a pipeline, he won't have any problem. And it would have been easier for me to also detect the error he was talking about. It was later on, and I had to mark about 499 students. So I couldn't spend more time looking for a problem for him, to look for where he had issues. But recently, as I was going through the code, because I had to review some part of the code, I saw where he had issues. And I used that code now. I said, I have to call the person. So I said, I want to write a journal, so I can tell him I'll put his name in the journal. The code is working fine. People are like, how did you do that? He did a fantastic job. He did a wonderful job. But because he did not use a pipelining scheduling or a pipelining system, he had issues along the way. He said, why do we use pipeline? Cleaner code. Consistency between training and what? Simplify deployment. A lot of people called me, hey, I couldn't deploy. Because why? They didn't use pipeline. So the Dockerizer was seeing the code in different patches. You didn't see it as just a compact as a compact unit. You have a class for 7, right?
That was, sir.
7 o'clock.
Yes, sir.
Okay. When it's 6:55, whenever we stop, we'll continue doing your practical, then we'll continue with practical, sir. I don't want you to go into the class again. At least you have 5 minutes if you want to drink water, the rest then you join the other class.
Yes, sir.
So when it's 6:55, we'll close for today, sir. That's it.
Yes, sir.
All right. Then look at an example of look at this, sir. This one I was telling you pipeline, import module. You can import a pipeline module for your library. So the step, you import a module. You can import the pipeline for preprocessing, for ML using scikit-learn. Maybe you call from scikit-learn, import data processing. You know all the data processing stages that you need. So you're not the one that will not streamline. Look at your data. Okay, I don't need to drop missing columns. I don't need to import scikit-learn machine learning models. You bring in SVM, you bring in training and things like that. So yeah, and that's one good thing about Python. Python already has this pipeline. You are not the one that should write the pipeline again. You already have the pipeline for you. All you need to do is know how to call them. Then now you yourself, you now define your pipeline. Create a sequence of combining them. How do I combine them? I start from importing my library, going to my preprocessing. So when you do that, by the time you are creating a Dockerizer, it has follow patterns. You want to deploy. You don't need anything. I think when I was writing my deployment code, it was taking me back. Yes, because some people want to put preprocessing before. There's a stage. Input before preprocessing. I hope you are getting it, sir. Then after preprocessing,
yes, sir.
You have model development. You cannot go and start with model development, sir.
Yes.
And say it won't work. Which data do you want to work on that you're starting with model development? So that's why I say what I say here, create a sequence of steps. So 1 more minute. So I will end with the last slide and we'll continue. So look at it. From anywhere you see sklearn, it's also what your scikit-learn. Can you see it? Yes, sir.
Yes, sir.
Import pipeline. Can you see now we have import pipeline? Processing, import standard. So see, linear model, import or linear regression. And you can see the way I've set the pipeline now. I've told it now. So anywhere I want to call the training of logistic regression, I don't need it again. All I need to go is go and call the pipeline. So you see how we write code that they will just be beautiful and you'll be wondering, wow, so this can be done. So let's stop here so that you can attend your other class.
Thank you very much, sir.